Here we're going to look at a couple of exponential applications, okay? And you're going to see how to set up and work with these exponential problems. Now, sometimes your application is going to give you the equation you have to use, and sometimes you have to be able to write it yourself. So in this first one, Jeremy deposits $6,500 into an account that is compounded continuously at 4.42%, and you need to determine how much will be in his account after 12 years. So here, this is going to use your compounding continuously equation, which is called the PERT equation. So it's PE to the RT, where this E is that specialized button on your calculator, base E. And so here you would have that A is equal to the 6,500 that Jeremy puts in, E raised to the 0.042, which is your rate, times 12 years. Okay, so here you just simply plug that through your calculator and you are going to come out with $10,759.64. Now this next one says the current population of a town in California is modeled by the function given of f of x equals 1066.058 times 1.0434 raised to the x, where x is the number of years after 2012. So the question is, what will the population in the town be in the year 2030? So the first thing you have to do is we have to figure out that x is going to be 2030 minus 2012, because it is the change from start to finish. So this is actually going to be 18 years. Once you figure that out, all you simply have to do is plug it in. So here we've got f of 18 is going to be 1066.058 times 1.0434 raised to the 18. And so what you want to do in your calculator is I would work this part first. So I would enter first and then multiply it by this last part. Okay? And so here when you're doing that, what I mean is you're going to take your calculator, so like this. Oops, let me move it over to the side so you don't have so much glare. And so we're going to take 1.0434 and we're going to raise it, so you got to use whatever your power button is. And we're raising it to the 18th and hit enter. Now on most scientific calculators, when you hit enter, this answer now is being housed as the answer in your memory. And so if you just simply then say multiply by, notice you get this ANS. You can see, so it says ANS right here. So this ANS stands for answer. It's pulling from the previous line down. And here I want to multiply it by 1066.058. So when you hit enter now, it's going to give you another result. Okay? And so here notice we have a decimal. So what we got is we got that f of 18 was equal to 2290.318. Now sometimes with these problems you have to use a little bit of common sense. So common sense would tell you that you can't have part of a person, because we're not being so specific as to think about you know, pregnancy or anything like that. So instead what we would say here is that in the year 2030 the population will be 2,290 people. So when you're dealing with the number of people that are affected or the number of people that are in your population, we generally round down to the nearest whole number instead of using the decimal form. Again, it does have to do with the context of your problem. But in a problem like this one here, you would be very safe to go ahead and round yourself down to the nearest person. Alright, the last one I wanted to give you is this one. It says a new virus has broken out in isolated parts of Africa and is spreading exponentially through tribal villages. The growth of this new virus can be modeled by the following formula, where P stands for the number of people in the village and D stands for the number of days since the virus first appeared. According to the equation, how many people in the tribe of 300 will be affected after 5 days? So in this case, what we know is that my P right here is going to be the number of people in the tribe, which we know is 300. The other thing we know is that my D here is going to be the number of days. So in this case, I can plug in the information that I have, which is that V is equal to 300 times 1 minus e to the negative 0.18 times 5. Again, you want to work for the innermost part of your problem out, and so here what we're going to end up with is 178.03. So to answer your question, we would say that roughly 178 people will be infected. After the 5 days. Okay. So one of the things that you'll notice when you're working these problems by hand is that it's really important that you make yourself a concluding statement or a concluding thought that really wraps up your equation or problem. Okay. So there you have it. 3 examples of different exponential functions using exponential equations and models. So if you have any questions, please let me know. Otherwise, I hope these examples helped, and I'll see you next time.